All right, hello everybody. Good evening. Today is Tuesday, March 4th, 2025, and this is the Fort Worth Astronomical Society Astrophotography Special Interest Group meeting for this month. Uh, and For this month, we are hosting two speakers. The first one will be Robert Cargill on how to stack images. This is sort of a beginner, newbie kind of session for people who are just getting into astrophotography and aren't really familiar with the different methods to do this. And I thought we've had a couple of more advanced uh, sessions. I thought we need to do one for the beginners who probably might be struggling with this. I know I certainly struggled with it 5 years ago when I started this. And so I thought it would be a good idea to have a tutorial on this using two different techniques. One being, I believe it's Astro Pixel Processor, which is what Robert will present with. And then I'll present on Pixinsight, which is the program that I use. Uh, Now, let me just check to make sure I've got sharing enabled for everybody here before I tell Robert to go for it. I think it should now be enabled. And without further ado, this is Robert Cargill. He's I think, one of the longest tenured members of our group. I'll let him introduce himself. He needs no introduction. He's very well known and respected in the group. Go ahead, Robert.
Thank you, Stephen. My name is Robert Cargill, and I did run the ASIC group meeting uh, when Jerry left it, when Jerry Gardner left it. Uh, then I branched out on my own group for the RAW meeting. I've been doing astrophotography since 2015. Then I really got serious about 2018, and the rest is history. Of course, here lately, I've been doing a lot of solar imaging and along with lunar. Not sure when I'm going to get back out to Rising Star to do some astrophotography. Hopefully soon. But anyways, uh, in order to stack multiple nights in Astro Pixel Processor, of course, you will need the software. Let's see, here it is. Can everybody see that?
We can.
Yes.
Uh, One thing, after you collect your data and stuff, your flats and darks and whatnot, you want to, let me back up for a minute. A couple of years ago, Bruce and I were out at Rising Star in October taking pictures for a couple of nights. And I wanted to take a picture of M45 for at least 10 hours for 2 nights. Well, a little problem with the camera kept on disconnecting for some reason. It would be like an hour, 3 hours, however. So once finally got all done with it, I took all the data from the previous hour shoots and I marked each one as like session 1, session 2, session 3, session 4, etc. So when you get ready to do multi-session, make sure you turn off the multi-channel because we're not doing multi-channel unless you're shooting SHO or RBGL. But you do want the multi-session processing because that will, excuse me, that will allow you to input different nights of data, including your flats and your lights. Darks, you don't have to worry about it because it's all going to be the same. So when we click on the lights, let me see here. Give me a minute. Okay, so I found some here of M13. So I want to just select a few of them. Oop. That one and that one. Okay, when you open it up, this window will pop open. Kind of forgive me, I haven't used APP in a few months. But anyway, you want to choose session 1. Okay, and then open up your lights again and select. Okay, for people that's new to APP, to select your files, click on one, come down halfway or so, click the shift button, then the left mouse button. Then you'll highlight the ones that you want. So this is going to ask again which one. So we're going to do session 2. We're going to say, okay. So next thing, we're going to select some more. We're going, no, I don't want you. Let's go here to here. Okay, we're going to open. So far, we got 3 sessions. So let's say we shot 3 nights worth of M13. So now we got 10 each from each night in there. So let's see about flats. How about that? I got my flats there. So same thing, pick the top one, come down, hold the shift key and left click, that'll open it up. So here's an interesting option. Now, remember that flats got to be taken every time. I know that's a whole nother subject, but we're going to do first session, but there's also another button that says all sessions. You don't want to do all sessions unless your optics are miraculously clean, perfect. So we're going to do that. We're going to open up some more flats. Same way.
Did it go away?
What's that?
And typically, FYI, on the sessions, I think it's useful to name the session like 3/2/24. So that's you took that March 2nd, 24. So then when you go to match up your flats and your darks or whatever calibration frames, then you match up the dates, because session 1 through 4, you might, if you took like 5 nights, you might forget, oh wait, which is which. So I try to make sure to name the session whatever the date it is I took it that night.
Very true, but with my 6200 camera, it kept on disconnecting. So I just used session 1 through 3 for that one night. Then the next night, I marked them as session 4, 5, and 6. So now we're going to go to our darks. Oh, where's my darks? Okay, since we're just using darks and they're good for 9 months out of the year. So we're only going to need one master dart right here. So now, since you got a master dart, now the thing is you don't want to put them on any of the sessions. You want to click the one that says all sessions. So by doing that, we got it all. Hold on, let me do the master dart flat as well. So we're going to click on all sessions as well. So I'm going to skip. Do y'all want me to go through the whole process? Or you want me to go ahead and skip to 6 and let it integrate?
I would recommend being as comprehensive as possible so that the beginners who see the video for the first time have as much information as possible, Robert, if you don't mind.
Okay. Let's go back to tab 0. Tab 0 is important because it's going to ask what pattern is your camera. Is it going to be red, green, green, blue, or green, blue, red, green, etc.? And when we get down to here, seem like somebody's kind of jibber jabbering. So we're going to just select ZWO as RGGB. Then we're going to force the CFA on it. I'm not sure what the CFA stands for. Let's see, color filter array. So that's what CFA stands for. Okay, we already done loaded all of our darks and flats and whatnot. Calibrate. I do not mess with that at all. Analyze stars. Leave it as it is. Normalize. Don't do anything there. As far as integrate, what I do here now, it says multi-sessions options. I never saw this. Integrate per session. I want to just integrate all of them all at one time. And then automatic, I usually do median. I want to just do average. And then on the no rejections has to do with, say, Elon Muskrat's Starlinks come flying through there. Well, you want to do sigma rejection because that will take out any satellites, airplanes, aliens, stuff of that nature.
Robert,
Yes.
every time I've looked at the tutorials that Mambala does, he recommends using the adaptive. And that's what I've always used.
Adaptive.
But just FYI, that's Mambala, who's one of the developers, said he likes the adaptive rejection.
Yeah, that's what I use too, Jim.
Could you please elaborate on that?
Well, that's just what Mambala is one of the designers of the program. And right. in a tutorial, he recommends using the adaptive. He thinks it's the best rejection. Now, okay. The mad rejection you use if you're wanting to like do comets and get rid of everything but the comet, but he recommended the adaptive, just FYI.
Okay, we'll try the adaptive then. As far as like any of the other numbers, the kappa high and kappa low, I don't change those. I do enable the MBB and I bring it up to 10%, and I believe that also helps get rid of some of the artifacts. Artificial artifacts, I want to say. Also, when you get down here, you want to set your save directory. So we'll go back up. I'm going to just put output because that's where it went. Open that. So now it's going to be saved there and click on integrate. And okay, this usually comes up. Type in M13. I'm going to put on there test. So now we probably wait maybe a couple of minutes And a good thing is always do a little bit of shortcuts by having the masters already done beforehand to help kind of cut down on processing time. When I did my M45 picture, it took 2.5 hours to process, even with my computer, with the full frame camera. A lot of data, 315 frames to process. And I noticed that the CPU temperature was jumping up to 70 degrees Celsius. But if you do not have a full frame camera, then you won't have a problem. Now it's analyzing stars. It gives you a score on it, the quality score. You can just kind of look through it, see how to improve your focus a little better. Usually, generally, the higher the number, the better the stars are going to result. And it's always a good thing to make sure you get the best focus possible. Usually during this time, y'all can go watch TV, get a snack, whatever. The good thing is with this computer I built up, doing data like from the 294 camera, it does it like in 5 minutes.
What type of computer is that, Robert?
It's a custom built computer. It has an i9 core processor. It's a 9th generation, so it is kind of old, but I do have liquid cooling also, and also got 128 gigabytes of RAM, along with a 750 power watt supply and a 8 gigabyte video card. So it's meant for some serious gaming too. So the better processor, better CPU, stuff like that will make it go a lot faster. I mainly built it because of the 6200 camera, because each file coming off that camera is 116 megabytes each. It doesn't matter if it's 8 thousandths of a second or 15 minutes. The data is still 116 megabytes. Now, the file coming off the 294 is roughly, I want to say, about under 20 megabytes.
Have you ever compared with a very good Mac?
I don't do Macs. Maybe somebody can chime in on that.
If you're running the later versions of APP, it's about 75% faster.
A Mac? Faster?
Than 1.083.
Oh, just let you know that APP, last time I bought it was, what was that? $285 or something like that. Or was it $185?
It's 160.
Yeah,
Okay.
it's not two.
Of course, I also bought the lifetime license, so.
Yeah, that's why it was more.
And there we are. We got a picture of M13 along with a little galaxy right here. and another galaxy right here. So I guess we'll run through a little bit of processing on it. Okay.
Robert, where was this taken? Did you say it was taken a rising star?
Yes.
Yeah, the gradient is pretty good.
So I'm going to do a batch crop. So I want to take one thing you want to do a crop for is kind of like when you're a kid, you don't like the crust on the bread. You want to get rid of this crusty stuff up here. See how it kind of looks like, yeah. That's one thing you want to kind of get rid of, and see how the mismatch is right here too. That's from guiding, because when you guide, the PH2 in ASI Air will step the pictures over. Every 3 frames, it'll move the camera over just a little bit in different directions in a random pattern. So that's the reason why you get this little mismatch up here on all corners. So I'm going to draw a green box like so. And this is typically how I crop the picture. And come over here, hit the crop key.
Excuse
And
me, Robert, are you doing post-processing right now?
I'm doing APP processing.
Okay.
If you use Pixinsight, don't do any of this. You report the raw fit straight into Pixinsight. If you do any kind of post processing on APP, Pixinsight can't solve it. So if you're using APP to stack and Pixinsight to process, once the stacking's done, you're done. Other than if you just want to see what APP can do. And it can do a pretty good job. It will not do as good a job as Pixinsight will do, but it can do a pretty decent job.
Also, one thing about Pixinsight is you can put all your stuff in there. It will stack it too, just as well.
Okay.
Another one I like to go to is the light removal pollution tool. This is a great little tool. You draw these little green boxes randomly. They got to be small, and try to keep any stars out of there too. I just put a few of them here and there. And what this does, it takes the gradient out. So when you're done there, you click on calculate, figure through, and the background just darkened up a little bit, which means that it removes some light pollution. We can do calibrate star color. Let's see, it needs one box. And this will help calibrate the star color. Sometimes I use it and sometimes I don't. And sometimes you can notice that the star colors do change just a little bit. Let's see. Got to move this out of the way. And generally on the right side, I just click on neutralize. It kind of helps neutralize the background, but you don't want to use it on nebulosity because it can take it out of there too. So as far as anything else down here, I do not touch. And I want to click on save. And I want to save it as a TIFF file. You want to keep it as a 16-bit because you want to extract every ounce of color out of there. And there we have it. And now, since you saved your picture, now you can open it up into Photoshop and continue editing it, adding the color, taking care of the background gradients, or not the gradients, but the background noise, stuff of that nature, adding a little bit more saturation to it. Oh yeah, let me add saturation here. Let's see. Sometimes I do use a saturation button and sometimes I don't because it does not work right sometimes. Any questions?
Robert, so this is so APP cannot do it all. You have to is you do mainly stacking and you move from there to another program to finish it up.
Yes. But with Pixinsight, you can do all the stacking in it, then you can finish it in there. And even some people has taken the picture finished in Pixinsight, and they'll even open it up in Photoshop to add a little bit more touches to it.
And I'm one of those people.
So, David, this is about as far as you can go in APP as far as having a finished picture. And once you're finished here, you just close it out, then you open it up in Photoshop, then you can continue there.
Okay. Do you think that that's the best way to go, or do you think that's for somebody like me the best thing? I know that it's gonna be painful, but it would be better just to start straight on PI.
Well, I'm not the only one that's going to say this, but Pixinsight has a very steep learning curve. And I tried starting out on it. I'm like, nope. But there's quite a few talented guys in this group that can help you out, but I'm not one of them.
David, David, if you're just starting and you haven't bought any program, I wouldn't buy APP and Pixinsight because you got to pay for both of them. I bought APP first and I would stack on APP, then I would take it into Photoshop. But then later I finally took the plunge into Pixinsight. And I still like APP to stack because it does it in 1/10 of the time as Pixinsight. Pixinsight stacking is egregiously slow, and unless you use their fast stack, but their fast stack's terrible. You don't want to use the fast stacks; it doesn't do as good a job. So APP will stack it massively quicker. APP does a better job on comets. It does a better job on mosaics. But you have to buy it and it's pretty expensive. So you'd have to buy it in Pixinsight. If I was just going to buy one program, I would buy Pixinsight and learn how to stack it and just realize it's going to take longer to stack. There are plenty of free stuff out there, though. You can get Deep Space Stacker that is free. You can get GIMP, which is similar to Photoshop, that is free. So you can try those and not have to pay anything. But if you're going to pay money, I say take the plunge and go into Pixinsight. There's plenty of people around here that can get you through it. It is a steep learning curve, but there's several tutorials that will show you 5 steps how to do it. And you can actually, Pixinsight's one of these things that there's 5 million processes. And the best of us, Stephen probably is the best. Chris is probably close with him. Maybe uses 50 or 60 of those 500 processes. I probably use 30. So Adam Block probably only uses half of them. But you can process a picture in Pixinsight with 5 processes, and it will be a pretty good picture. But as you learn, you'll learn other steps that make it better and better. And there's tons of scripts you can get that will do everything, that will do a lot of it for you. So Pixinsight is ultimately more powerful tool than APP overall. So if I was going to buy one, if I started over, I would just make the plunge and buy Pixinsight. That's my advice. I'll let other people talk.
Thank you, Jim.
Hey, Jim.
Yes.
What is it you don't like about the fast batch processing?
I don't think it's as clear. I think it's it doesn't seem to give you as good of results when I do the fast versus the full one. And when I do the fast and compare it to my APMP, I see artifacts, and it doesn't seem very sharp.
Okay, I've been using the fast batch processing, but maybe I'll do
I just don't think it does.
I'll do a weighted batch process as well, just for comparison. But the fast one is really fast. I mean, 15 minutes.
And speaking of Pixinsight, I'll go ahead and kind of go over some of these processes. One of the things I'd first like to talk about with Pixinsight is how to organize your files so that when you use Pixinsight, it's a little bit more seamless. And if you have it organized from the start, this will make your experience with Pixinsight a little bit easier. So, by way of example, what I'm going to begin with is I've got NGC 1499 that I captured with my Red Cat telescope. And if I share my screen, hopefully you'll be able to see this. Let's see, screen share. And right, so you should be seeing my my file called NGC 1499 California Nebula Red Cat 51. That's the name of the telescope that I used, the optics I used. And the first thing I do is, because I try to get as much, at least 8 hours of data for each target, I'll typically have at least 2 sessions. So I'll have a session 1, a session 2, and oftentimes many others, depending on the target. So I've got one file with all of my session 1 data. And in this particular case, for this example, I've only selected 5 light frames to stack, but those 5 light frames require flat frames, right? And I've got, I don't know, about 20 of those, I bet. Let's see. I've got 34 flat files for some reason. I don't know why there's 34. And then I've got dark files, which, depending on your camera, you might not need dark files, because typically dark frames, dark calibration frames, are needed for the purpose of removing amp glow. Some cameras have amp glow and some do not. I'm going to make no assumptions on the kind of cameras people are going to be using, so I'm going to include this as if you might have some amp glow in your camera. People also recommend getting dark files or dark calibration frames that are the same duration as the flat frames. So my flat frames here, taken with the ASI Air, were 116.7 milliseconds. So I've got darks to correspond to those of the same amount of time. And so that's for session 1. And session 2, I have virtually the same thing, only the lights were taken on a different day. The flats and the darks, they're in separate files, session 1 and session 2. Now, I've done the same thing with, and that was with a one-shot color camera. I also have data here, which I took with a mono camera, where I've got light files for the blue channel. I've got 5 frames from the blue channel, 5 or 6. I've got approximately 5 for the green channel and approximately 5 for the red channel. But once again, you have to have corresponding flat frames. And the flat frames have to be taken for each filter separately, right? At the same focus, right? Because the focus will change from one filter to another. So I've got flat files for the red channel, I've got flat files for the green channel, and I've got flat calibration frames for the blue channel. In this particular case, I didn't include the dark frames into this file. We'll go grab those in just a moment because I've got a dark library, and we will use dark frames for this data also. Okay, so that's how I organize the data. For the one-shot color, it's in 2 different sessions. And if I had taken, if I had separate sessions for the mono camera, I would have organized this in the same way. So I would have session 1, and then I might have red, green, and blue, plus the flat files, and then session 2, red, green, and blue, plus the flat files. Okay, so that's how I would organize the data. And this allows me to better keep the data segregated so that it doesn't inadvertently overlap, and I don't inadvertently, because I've done this, stack the wrong files with the wrong data. So as a history major and sociology double major, I had no scientific training. I've had to teach myself all of the little details that a lot of people with science background probably would understand off the top of my head. I didn't have that kind of training. I've had to teach myself how to do this independently. Okay, so now let's go into Pixinsight. And hopefully you now see you should see my Pixinsight screen. And to stack this data separately, I'm going to go to Script, and I'm going to go to Batch Processing, Weighted Batch Preprocessing. And hopefully that's going to load here in just a moment. And here's the screen that you get. Now, because I've organized my data in the way that I have, for the one-shot color data, I can just go directly to Directory, and I can click on Directory, right? So here's my desktop with a bunch of different files on here. And so if we start with the NGC 1499 California Nebula Red Cat 51, and we select that folder, all of that data is going to immediately be populated. And you can now see that I've got 5 frames under one session and 5 frames under a second. Since I've got 2 separate sessions, I have to group by keyword. And I'm using session as the keyword. So I'm going to double click that so that the word session appears under the grouping. Now, when I slide over here for this data, you can see that here's session 1, and this session illuminates these flat frames, and it illuminates these dark frames. If I go to session 2, you'll see this change. Now you see that it is illuminating these flat files and these dark frames. So it automatically, by clicking this word session, it automatically matches up the flat frames and the dark frames with the light frames to be calibrated. And it gives me a green check mark. Now, if I had inadvertently failed, let's just clear this off for a moment. Let's say I had inadvertently failed to include any flats or any darks. Then when you look at this under the calibration tab here, it's got a yellow caution sign and some warnings. No matching master bias, dark, master flats, warning, warning, etc. So to avoid that, what I do is I put all of those files in the same directory so that I don't have to worry about that. It's going to go back, it's going to grab everything, and now I've got nice green check marks. What you can do is just to see, well, gee, what does all this do? How does this work? I mean, why do I have these calibration files? What's it about to do? If you're curious, it says show calibration diagram right down here, right? So if I click on show calibration diagram for session 1, it's going to say that it's going to take the light frames, it's going to subtract the master dark, which gets rid of the amp glow. And if you don't dither, it'll get rid of hot pixels, right? If you dither and have a good camera, you probably don't need dark frames at all. But after it subtracts the master dark, it will then divide that by the master flat to give you the calibrated light. And then it will stack and integrate the images. So you'll get one of those for each of the sessions. And this shows you, okay, I must have done it right. It's showing that it's subtracting the master dark, dividing by the master flat, giving me a calibrated light. Okay, well, here's the information. It looks like it's all loaded. Is there anything else that I need to do? Well, that's what the post-calibration tab will let you do.
Quick question for you, Stephen.
I'm sorry, say again now?
A quick question for you. I noticed you're not using any bias.
Right. So bias frames are not needed if you have dark frames and flats. I could include my bias frames. And in fact, let's do that. Let's go grab my one-shot color bias, and I'll show you why they're not needed, right? We'll go to the directory where I've got my dark library, my one-shot color dark library for the duo, and I've got my bias frames right here. So we'll select that folder, and let's pull those in. Okay, it's got 100 bias frames, and they're located right up here, right? But as you can see, for the first session, it's not illuminating the bias.
Because you're not telling it to use it.
That's because it doesn't need to use it. See,
Well,
it's going through here, and it's just going to subtract the master dark. It's going to divide by the master flat and divide by the calibrated, or divide by the master flat, right?
well, what's the theory for not using the bias?
Okay,
The bias is meant to take out
so
the camera's electronic noise, right?
so the bias frames can be used in place of the lack of a master dark that matches the light the light file. So, by way of example, let's get rid of my dark frames, okay? And we'll get rid of my
Steven,
bias.
may I ask you something before you proceed?
Yes, David.
Eh, when you talk about darks, you mean dark frames,
Correct.
right?
I
And
do.
when you say flat, you're talking about flat frames, no flat darks. Is
Correct.
that
So there
correct?
there are dark flames, there are dark calibration frames, flat calibration frames, and then you have dark flat frames or flat dark frames. I always forget which
Right.
the correct terminology. It's either dark flat or flat dark. I get it
But in
mixed.
your first example, you were not talking about flat darks, right? Just dark frames and
Right. Well, I did have them in there, and I'll show those to you in just a moment, David. That those were in there.
Hey,
Um,
Stephen, let's chat offline. I don't want to take the,
well, since I've already gone down this path,
okay.
here's my light path, which says neither bias nor dark master file matches light frames, blah blah blah. Um, so what I can do is if I include my bias files, right, I can use the bias will now be used to calibrate the flat frames. Okay. So now these bias frames are going to be used to calibrate the flats. So if you don't have corresponding dark frames for the flats, you can use bias frames instead. But since I do have them, we'll clear this out. Since we do have them, I can just go into my directory because I've got all of my data there, right? So here's the Red Cat data. I'm going to select that folder. And to answer David's question about the flat darks, they're actually there because here's the flat frames, these 0.12 seconds, they are going to be, so the flat frames are going to be calibrated by subtracting a master dark of 0.12 seconds because I've got 30 frames at 0.12 seconds, which are going to be used to calibrate the flats. So these, David, are the flat darks that you were referencing earlier, right? So we now have the flat darks, which are 0.12 seconds, and we have the dark frames, which are 300 seconds. And it's all here. Now, and I need to make sure I have the word session clicked here. So I've now got 50 minutes of data. I could choose to drizzle the data right here, and it'll take a little while if I choose to drizzle the data because it's just a longer process, but it is highly recommended. And so I'll go ahead and I'll click that and we'll see how long that takes, right?
And what is drizzle in this context?
Okay, so drizzling is a process by which the data is actually, I guess the best way that I can explain it is to say it goes through and it takes every pixel and it compares it to the pixels around it so that the data can be, I don't know, best optimized. And after going through an optimization process, it creates a much larger file where the stars are sharper and the nebulosity is sharper. That's
Best
probably
description I've heard ever. Thank you.
the easiest way that I can describe it. Adam Block could explain it much better, but that's the
Thank
best
you.
I can say under for right now. I'm not going to click fast integration at this point. I don't think I need to do that. I don't want to have fast integration because it does tend to produce images which aren't optimal. If you want the best quality images, in my opinion, I don't use fast integration. Now that I've got the drizzle checked, now let's look at the pipeline. We don't use linear defects correction unless you expect that there's some kind of linear defect in your data. And in fact, quite honestly, with modern cameras, I don't expect that many people will actually use this, and I would expect Pixinsight eventually to exclude this category in the future. It'll do subframe weighting, which basically means it's going to go through and the software is going to evaluate the data. And the data that is best will have a heavier weighting than data that it believes is not as good. And that data will be weighted heavier in the integration process. It will register the images. That means it's going to align the stars. It will then normalize the data. Don't ask me to explain that one. It's a very complicated process, and it's a very complicated concept. Adam Block does an excellent job explaining it. I don't have the gray matter to explain it the way he does, so I'm not even going to try. But it normalizes the data. Then image integration, which is the integration of all of the pixels that have gone through this process and combined into a single image. Now I'm going to click diagnostics. Well, before I do that, I'm going to select an output directory. And I've chosen a directory on my desktop, which is weighted batch preprocessing all files. Okay, I'm going to select that folder. That's where a bunch of information is going to go in the process as it does this. I'm going to click diagnostics, and it's going to tell me that I have no bias frames, but I don't need them. And it's telling me that to drizzle, it typically requires more than 15 frames to produce optimal results. Well, for today's demonstration, we only have 5 frames to speed up the process. You should drizzle your data, and so typically you would need 15 frames or more to get the optimal results, but you can still do it if you don't have 15. It's going to tell me how much disk space is going to be needed, and everything's in green. It's telling me that I've got plenty of working space available. So it performs that projection for you so that you don't get a bad surprise where after waiting for this to process, you find out, oh no, I don't have enough data available, enough storage on my computer. All right, so everything is looking green. I'm going to click run. And it gives me basically the same diagnostic message that I had a moment ago. And I'm going to click continue. And here's the menu of things that are going to occur. First, it's going to integrate the dark frames for session 1, the dark frames for session 2. It's going to integrate the flat darks from session 1 and the flat frames for session 2. And I'm getting a message here that says that low system resources may affect my audio quality. Hopefully you can hear me okay. And that's
Yes, sir.
because Pixinsight takes a lot of computational power, and it just does. So meanwhile, while it's going through this process, I see that it's integrated some of the dark frames, and it's going to go through this very long process of doing all of these things. Okay. But the good news is I've already done all of this. So we don't have to sit here for, I don't know, 30 or 45 minutes. If it starts taking a really long time, I'm going to click cancel because I've already done this and I've got the data already completed. But let's just, for grins, see how long this might take. I'm going to go get another cup of coffee in my mug, typo man, righter of wrongs, and then I'll be right back.
I would like to add one thing about bias frames. Yes, you can use bias frames for these CMOS sensors, especially these cameras, but bias frames are mainly for DSLRs because since they're uncooled sensors. Just FYI.
All right. Thank you for telling us that, Robert. That's new information for me. Good to know.
Yeah.
And I used to exclusively use a DSLR camera.
And
So that makes sense
Now,
to
Stephen,
me.
I got one more thing. Just because these new cameras have no amp glow, you should still take darks just for cosmetic reasons. Because my 6200 is lit up with a bunch of red, green, blue, and white pixels. So just having a few, you don't need a lot, just need a few just for cosmetic purposes. FYI.
Okay, so that's to reduce the hot pixels.
Hot and cold.
Yeah, the hot and cold.
Yeah.
And
I won't get into arguing this now. We can take it off subject, but I've tried both and found you don't need darks, in my opinion. But
I
we can
think
talk
it's
about this later.
honestly, I think it's camera dependent. I've read that in on my 2600 on my monochrome. I definitely need darks. Not so much on the 2600 color camera, but the color camera is new, so it doesn't have very many or enough hot or cold pixels. I think it make a difference, but definitely on the mono, my experience is I get better results with darks and biases, but I think to each his own.
Yeah.
just FYI.
Thank you, Robert.
Welcome, Kennedy.
There really is. If you go on some of the various web pages, Cloudy Nights, even the Facebook pages, there's a lot of people with strong opinions about whether or not certain cameras need bias and need darks, etc. The various arguments might be that, okay, if you're dithering, which means you're waiting for after every image, you're waiting for the stars to move slightly before you start your next image, that when you then calibrate, the hot pixels and the cold pixels will be calibrated out. Now, I'm not a software programmer. I can't verify this, but that's the argument that some people make.
Yeah, Stephen, I've heard the same thing, and I do dither, and I think that does. And I go by the Lazy Geek did a big, huge deal on it. Everyone can look at his, but yeah, I think if you dither, I don't think you need the darks, and you don't have amp glow. But to each their own.
Exactly. So, and that's why for today's purpose, I included darks and flat darks, dark flats. Which is it, Robert?
It's either way.
Okay. All right. that's why I chose to include dark calibration frames for both the flats and the lights, so that a person can choose to include them or not, and they can experiment for themselves. Following the Lazy Geek, I'm also a member of his channel, and I also typically, if I was doing this just for me, I would not have included darks, only because, like the Lazy Geek, I just don't think they're needed. But I'm not going to weigh in on that controversy for this tutorial. This is teach people a thing or two, right? That at least that I've learned over the years, and now you can see why sometimes people will complain that Pixinsight is a very long process because we've been sitting here for a few minutes. It's gone through a list of things. Now it's doing the local normalization. And then it will begin the integration process, right?
Can I butt in for a minute?
Oh, absolutely, Robert.
Okay, I got the Holy Grail book here,
Okay.
the Deep Sky Imaging Primer, and back in the index section under F's, it's called Flat Darks.
Okay. So flat darks. Oh, hold on just a moment. Yes, I had that book also. Here we go. And actually, when I first started out, this book, this is, I mean, I had, as you can see, I've got some of the pages like tabbed and highlighted, and I've got like, little pink squares around stuff that I wanted to remember and not forget. So yeah, this is a very good book. If you're gonna invest in a hard copy, I've got the second edition. Hopefully, they've got another more up-to-date edition of this book. But this isn't a bad book to get. It explains.
The third edition is out.
The third edition is out. Okay, good.
Yes.
Yeah, I'm doing the third edition. Yeah.
And it's I think you can get it in paperback, but it's also available PDF file.
Yeah, I got mine in hard copy because, well, I just like I'm old school, and I like to have it in my hand where I can find the pages and do that kind of thing. But a lot of people, prefer the PDF. You can do searches, that kind of thing, Control F, that kind of thing. All right. So we're past integration, looks like, and it's doing the drizzle process. Good. That's a good sign. Now we're in auto crop. So one of the things that Robert showed you is cropping the image. One of the things that Pixinsight will do for you is it will automatically crop the image, and which it did to successfully, it successfully cropped the images. Both the regular integration and the drizzle have now been cropped, and it's now running the Astrometric solution so that you have files that can be used later on for things such as spectrophotometric calibration. Hopefully I said that correctly. And that requires an
color calibration.
That's right. Spectrophotometric color calibration, supercalifragilisticexpialidocious, requires the astrometric solution that's doing it for you as part of the weight batch pre-processing thing. All right. Whew. Okay. So I don't know how long that took. It's got the elapsed time here done. Let's take a look at what we got. All right. Here's what it did. Now I'm going to get out of that and I'm going to open that file or open the files, right? So I put it in, remember, weighted batch pre-processing all files on my desktop. Here's all the calibrated files in here for the flats and the lights for session 1 and session 2. Here are the debayed files. It has a log, but actually I don't see a log in there. It has the registered or star aligned files, and they're all here. And the master files. So it's got the master lights, the master flats, the master darks, and a reference light. Okay, so I did a drizzle and a non-drizzle, right? And then Bob asked, well, what's the difference between the two? Well, since we've got both of those images, we can compare them. And we can see that the drizzle file, hopefully, looks slightly better than the non-drizzled file, hopefully. All right, so we'll open the drizzle autocrop and the regular non-drizzled autocrop, and let's open those and let's see what we get. Okay, so you'll get 4 frames that open. The first one shows you what was cropped out, right? So if you come over here, there's this little nuclear button here. It's a screen transfer function, is what it's technically called. And this shows you the data that was automatically taken out. So there's this I don't know if you can see it. See this white area here? This is the data that was cropped out on all 4 sides. So it did that for me automatically so that I don't have to guess. It figures out the right way and the most efficient way to crop it so that the bad data is out. So the bad data is out. All right. Here's the stacked image. And now let's hit the nuclear button, which performs a stretch on the data. And oh my gosh, this looks ugly. It's green. How can this be? Well, that's because the screen transfer function is linked, but if I hit the control button and the nuke button, now you've got some data that actually looks a little bit like the California nebula, right? There it is. Voila. And here's what some of the stars look like. Let's look at some of the corners. Let's see if I've got any back focus issues. I don't know. Those stars are looking pretty good on the corners. Not perfect, but very good. Okay, I'm happy with that. And that's only 5 frames of data. Now let's look at the the auto crop for the drizzle is going to be identical because it crops them consistently. So it's the exact same crop. So these two will line up exactly if we compare them. Here's the drizzled file. Now let's take a look at an example of a drizzled star versus a non-drizzled star, right? This is the drizzle. Here's the not drizzle. And if I take this little tab here and I move it over to this file, it will line them up so that I've got the exact same view for both of these. And somehow I've got to get rid of, all right, I have to do something here in Pixinsight because my little box is going to interfere. Okay. Now I'll share my screen again and you'll see what I'm talking about. Okay. So the drizzled file is slightly different. Here's the drizzle file on the left, and that's what it looks like. And here's what it looks like not drizzled. So if we had a lot more data, you'd probably see a larger difference. But let's take a look at some of these other stars, for example. This star right here, you can see a little green to the left on the drizzle. You don't see that on the non-drizzle, right? If you come over here on the non-drizzle and you look at this star, you only see like 6 pixels of light. Over here, you've got an additional pixel on the top, an additional pixel on the bottom with light. This file over here, you see 3 by 4. Over here, you've also got 3 by 4, but there's also some very faint data on the sides. So in the drizzle process, it creates a higher resolution image, and that's why it's a good idea to do the drizzle. Okay, it does take a little bit longer, but the files themselves and the star quality will be better, and it also translates into better data for the nebulosity, right?
Stephen, can you show me the file size for that?
Oh, the file size, sure. Let's take a look at that. Good point. Let me stop the screen share here, and let's look at the weighted batch pre-processing, and let's take a look at the file size, which will actually reinforce, hopefully, what I just said. There's zoom, and here's. So you should be able to see that the drizzle autocrop, well, all right, I might be, the drizzle autocrop is 414. Now the drizzle file was 625. The regular RGB autocrop is 414, and the non-drizzle RGB was 931. Okay, riddle me that one, Batman. I was expecting the drizzle file to be larger. Oh, that's because I did it at 1x.
Right. I was going to say you selected 1 and I would select 2.
Right. So if I were to have selected 2x drizzle, the file would be considerably larger. So I had, for speed purposes, only chose 1x drizzle. The standard is 2x drizzle, which will give you a much larger file size.
Right. And that's why you didn't really see a big difference between the 2 images.
Right. And again, we did that for purposes of demonstrating the proof of concept. Now let's do something a little bit different. Let's go back to Pixinsight, and we'll just minimize these files here. The other thing with Pixinsight that you can do is you can rename these. I'll call it, this is OSC drizzle. Okay, so that's there. And then instead of having this really long file name there. So I've got little differentiations. So now I don't have this mile long file name in the screen there. Now let's do the exact same thing, but let's change it up a little bit, and let's go and use that other data that I referenced earlier, which was from the other optics. Remember, I have data that's from the William Optics 111, which includes a mono camera, and I've got, for this, I've got data from the blue filter, the green filter, and the red filter. I've got flats for the blue, green, and red. Now, I did not include any darks, okay? So let's just say, now I can go ahead and grab that data if I want to from my dark directory. I'll just go ahead and grab that. That was 300 seconds, right? Yes. Okay, so I've now got the dark frames, and I'm going to go ahead and grab, I believe I've got some flat darks that, some old data that's 17 milliseconds that should work. All right, let's go and see what the calibration says. Okay, so we've got a bunch of green check marks here, which is good. That means that for the red filter, it's going to calibrate it against the dark frames that are 300 seconds and the flat frames that are 0.7 seconds. And it's going to calibrate the flat frames using this 0.02 second dark frame that I've got, right? And it's going to do the same thing for the green. It's going to do that for the blue and everything. And if you want to look at the calibration diagram, we've got the same thing. We've got for the red filter, it's going to subtract the master dark. It's going to divide by the flat to give us the calibrated data.
You're not sharing the screen, Stephen, just for you to know.
Silly me. Sorry. Thank you so much for letting me know that. I apologize. I didn't been over here talking as if you could see what I've got here, right? Okay. So let me just start over in case I didn't, in case you all need to see this. So I'm going to grab the directory for the data that's from the William Optics 111, and it's going to populate that data here, but I don't have the dark files. So I'm going to go to my dark file library. I'm going to grab the dark frames from my dark library. Here's the 300-second frames, which will correspond to the 300-second light frames. And then if I want the dark flats, I'm going to go grab that data from my dark library. And here's the 17 millisecond data, which I'm going to use for that purpose. So now I've got all of the green check marks showing that the calibration diagram is going to follow the same calibration that we discussed earlier. I'm going to just put it in the same output directory, and for the post calibration, I'll go ahead and I'll scale it to 2 for the drizzle, which is how I would normally do it. And because I've got several groups here, I want to apply it to all the groups, which means I want the blue filter data drizzled, the green filter data drizzled, and the red filter data drizzled. And I don't have an option necessarily to take this off of fast unless I unclick this check mark, right? But I'm going to go ahead and click the fast mode for our purposes today so that it gets this done maybe a little bit quicker. And I'm also going to use fast integration to try to speed things up a little bit. Now, I'm telling you that when you use fast integration, in my opinion, the processed image isn't quite as good as if you take the time to have it go through the standard process. But for our purpose today, I'm going to enable it to speed this up a little bit, so it'll be a little bit faster at the expense of quality, which I normally would not do. Okay, I'm just going to put this all in this directory down here. I'm going to check the diagnostics. It's going to give me the warning that the drizzle integration generally requires 15 frames for optimal results, but otherwise I've got sufficient space on the hard disk to get all of this done. And I'm just going to click OK, and I'm going to click Run, and I'm going to click Continue. And now it's going to do the exact same thing. Now we're using a different optics. We're using the William Optics 111 millimeter, the Pleiades 111 telescope, which is a much larger telescope. The focal length is, I think, approximately 500 plus or minus millimeters is the focal length on that one. And once again, I'm getting the warning that low system resources may affect my audio. Sorry about that. But it's going to run through this same sort of menu of things that it's going to do. It's going to integrate the dark frames. It's going to calibrate the flat frames. Then it's going to integrate the green. Then it's going to calibrate the red. Then it's going to calibrate the blue, et cetera, et cetera. And then it will eventually perform a fast integration of the blue, the green, the red, et cetera. And it's working on that right now. And hopefully this won't take too long. This is about the time when I would probably take the dog out or throw a load of laundry in and just let this run, because it'll take a couple of minutes. And while it's doing this, I'll stop my screen share for the moment and just ask if anybody has any general questions while that's running. Yes, Robert.
I gotta go.
Oh.
I gotta get to bed.
Yes, sir.
Get up early.
Thank you for coming, Robert. I greatly appreciate. Time and time again, Robert Cargill is always the first one to volunteer if I go and ask, hey, Robert, would you do a tutorial on XYZ? And Robert never, ever says no. So thank you, Robert. It is greatly appreciated.
I appreciate you having me on, Stephen. I'll see all you guys later.
Thank you so much,
Right.
Robert.
See you, Robert.
Bye.
All right. Let's see how we're doing.
So, Stephen, I have a question.
Yes, sir.
So when I'm integrating images with different times, different exposure times, in the weighting process, I find that the PI process eliminates all the low exposure frames. And how do you cope with that?
It eliminates them?
Yeah, it weights them out because their signaling is so weak compared with the longer exposure.
Okay. Yeah. All right. I know what you're talking about now. So there is so the first thing you do is you change the tolerances to like 2 seconds, right? So if you've got some 120 seconds and some 300 seconds and some 600 seconds, if you change the tolerance to only 2 seconds, then it will it'll create separate master lights for each image. And you'll get separate registered images for each data set. So you'll end up, let's say you've got 30 that were 1 minute frames or subs, and you've got 30 that were 5 minute subs. If you change the tolerance so that Pixinsight is forced to register the images separately, you'll end up with a bunch of registration frames corresponding to each time limit. Then what you can do is go to image integration and put in, actually what I would do is I would go to subframe selector, and then I would go through the process of evaluating the subframes myself. In any event, you'll end up with registered images that you can put into image integration, so you can force it to integrate all of the files together. And using image integration, you can tell it how to weight the images. So you can tell Pixinsight that you want it to weight the images based on signal to noise ratio, or on some other formula or some other criteria that you select. And that's up to you. You're the cook. So you can decide how you want it to weight those images. And I think there's one in there to weight them all equally, as I recall. I'm going from memory. And then it's just going to take all that data and it's just going to throw it together and integrate it without weighting it at all. I think that's a procedure you can use. I haven't done that recently. I have done that in the past, though, for some of the group projects to make sure I get as much data as possible.
So there's no way in WBPP to do that all automatically. You use the outputs from WBPP and then you go into image integration, do it manually.
That's what I've done.
Okay.
There might be a way to use WBPP, but I haven't done that recently. I've always used the manual image integration process when I have that situation.
Do you use the high dynamic range integration tool?
I have used that, and I've found that it's not as good, but that's just my experience. I've found that when I manually tell it to integrate all of those images under image integration, I found, generally speaking, that, at least in my opinion, I get better data. Then, of course, what you have to do is then you have to open the process for manual drizzle integration. And then you have to, do the exact same thing after you integrate the data. So that gives you two separate steps, but that's the way that you can perform the process that you're talking about. And I think we're almost done. It's doing the astrometric solution. So I'll share my screen again, and we can see that it solved the, which one is this? The blue. It solved the green, and it's solving the red. And it did the integration times at 2x. So hopefully this will prove us correct, Christopher, that the 2x drizzle files are going to be larger than the other files because it's 2x.
They should be 4 times fast, larger.
We'll test that. I was gonna say it would be substantially larger. 4x is probably correct.
Well, it doubles the screen resolution, the image resolution, both vertical and horizontally.
Okay, there you go. And it's probably got about another 10 seconds left if these times are any indication on how long it's going to take to finish the astrometric solution.
By the way, I have, Stephen, while you were talking, I've got an example on my desktop of drizzle and not drizzle, which shows you a big difference.
Okay, all right, well, hold on. I'll stop sharing so you can do that. Go ahead.
Okay, now hold on, I need to share that right there. And screen 2. Can you see that?
Nope.
Oh, gosh, share.
Okay, looks like something
Now,
about to happen.
I hope you're seeing that.
Well, we're
I'm
seeing
screen-
your, looks like the
it's the Flame Nebula.
Flame Nebula, but I
Okay,
don't see
so just
file size.
I'll go. All right, I just took this. This is with my new FMA 180.
Okay,
Gives me a huge field of view with the 6200 one-shot color. Okay, and I'm just gonna. Sorry, this Ryan's belt corrected. I ran Blur Exterminator on it just to correct the stars in the corners. But this one is drizzled, and I'm going to zoom in on the Flame Nebula just because. Okay, this one's drizzled, and the one on the right is not drizzled. It's exactly the same set of files, and you could see how good the stars look. And I used fast integration, so maybe I'd get a better result with the weighted batch processing. But I mean, you can see how much more detailed the one on the left is, especially when you look at the stars compared with the one on the right.
okay. Very good.
Just on file size, I mean, the file sizes are like dreadful.
Right. And I'm actually seeing that right now. I was just checking my size and you're right.
So here's my single master file, Ryan Belt corrected, that meaning it's been blur exterminated. And this one's drizzled and it's 2.8 gigabytes, just one image.
That's a large file.
It is a large file.
That's a large file. All right.
That was it. I just wanted to show that.
Yeah, thank you for doing that. I appreciate it. Let's take a look, and I'll show people the same thing from File Explorer here. Hopefully, you can see that the red mono drizzle 2x is 881 megs, and the same under fast integration auto crop is 220, right? So.
Yep.
4 times 2 is 8. And even a history major can see that. Okay. We'll stop that screen share. And now let's actually look at what the data produced. So for that, we'll go to Pixinsight. We'll get rid of the weighted batch pre-processing file. And now let's open these and see what they look like. Let's see here. Okay. So here's the red 2x autocrop. Here's the green 2x autocrop. And here's the blue 2x autocrop. We're going to open these. And as before, We have a lot of windows. Some of them show you what the data is that was cropped out, which we don't need. So here's the red file. And so we'll run a quick screen transfer function on that. So here's the red data. This is the crop or the green. Let's do a screen transfer function on that. Let's do a screen transfer function on that, he said. Okay, there's the green data. This should be the crop for the blue, I think. Yes, it is. So now let's run a screen transfer function on the blue. And not much there. Okay. All right. So now what we can do is combine these really quick. Process, all processes, channel combination. Just to show you what it sort of looks like when you combine the channels. Channel combination. There it is. And I'm going to go and I'm just going to take the red and put it in the red channel. I'm going to take the green and put it in the green channel. And I'm going to take the blue, put it in the blue channel. Okay. And I'm going to click the little circle, which combines them all together. And here's what it will look like, sort of. So here it is. I think this needs some further cropping because I don't like what's happening down here. But let's see, I'm just going to get rid of that. I don't know why it didn't do that for me. It should have. Okay. So here we have the California Nebula with the red, green, and blue channels combined. If we were to, and it looks like I must have had, looks like I've got a little bit of a diffraction spike going on here. This might have been back when I had some of my gray hair falling out onto my filters. And I think it created a diffraction spike. I had that issue a while back. I cleaned the filters and this went away. But this is data left over from that. In any event, this is how it looks once you've combined all three channels. There's a lot of other things I would do to this before I combine the data. But this will give you an example of what it looks like. Now, let's do the same thing for the non-drizzled data, right? So let's take just the fast integration auto crop for the red, the fast integration auto crop for the green, and the fast integration auto crop for the blue. All right. We're going to get a bunch of screens that we don't need again. There's, okay, so here's the red, which has not been drizzled. This should show me what the crop looks like for the green. Let's take a look at the green. There's the green file. And this should be the crop for the blue. We don't need that. Here's the blue. And there's the blue data. Now I'm going to do a channel combination for the non-drizzled data, right? So we're going to put the red non-drizzled data. Here it is. There. Okay. We're going to take the green non-drizzled data, put that there. Okay. And we can take the blue non-drizzle data. There it is. And put that there. So RGB. Okay. Now we'll click this button. And I'm going to put this over here to the side because I'm going to use this process again in a moment here. Okay, so here's the non-drizzled data. And it doesn't look nearly as neat as this data over here. In fact, it kind of looks a little blown out, and I'm not quite sure why that is. Probably because I used fast integration. This is why I don't like fast integration. It doesn't look as good. It looks like it needs a lot of post-processing work. It's extremely noisy. This is why I really do not care for fast integration at all. But if you look at some of these stars over here, and compare it over here, you can see that the stars that were drizzled look a lot better than the stars we have over here for the data that was not drizzled. So drizzle, I highly recommend. I would never not drizzle. I guess I should say I would always drizzle. All right, now let's try one more fun thing, and then we'll open it up for questions. We're going to create what is called an SHO image, or the Hubble palette, where we put the green data. Well, it's SHO. It's really, I'm going to put the green in the red channel. It's not quite SHO, but it's kind of like that, right? So I'm going to put the green drizzle data in the red channel. I'm going to put the red drizzle data in the green channel, right? And I'm going to put the blue drizzled data in the blue channel. If I can, where is it? Drizzle blue. Okay. All right. So I've got green GRB, drizzle. And this is how you would typically create, if you had sulfur, hydrogen, oxygen, this is how you would combine that data to get an SHO image, which is going to look something different. Okay, so now we've got purple stars, which is typical when you use this technique. And again, I don't know why it didn't crop things the way I would have expected it to. So I'm just going to create a preview and then drop the preview over here. And so this is how you would normally create SHO data. From this, you could run the process, for example, SCNR, which takes out a lot of the green. And now it's turned purple. I don't like that at all. So I can go back and take that out, right? If I want to do some other things to this, I might try running a script down here, correct magenta stars to get rid of the magenta stars on this, and it'll automatically do that. So it's supposed to take the magenta out of the stars, but still looks kind of purplish to me. In any event, this is how you would create an SHO image with sulfur, hydrogen, and oxygen data. And you can take this image and process it from here. I'm going to stop my screen share and show you that this process is, it's it takes a long time to learn. It takes a lot of effort, but I think if you practice this and just spend just 15 minutes a day um, playing with your post processing, using different techniques, watching various videos, you can really improve your post processing. And to demonstrate that, what I'd like to show you is some of my early images, which really were awful. So I should probably stop the recording at this point because I'm so embarrassed by this, but I won't. I'm going to show you some of my really bad first images. Okay. Now, here was on October 13, 2020. Can you see this? I don't know if you're seeing a really bad image of Andromeda or not.
We can see your mouse over that image.
Okay, so you can see a very bad image of Andromeda.
Very small.
Oh, very small image.
Double click it.
Okay, hold on. Let me try something. Now let me. There we go. Now can you see a really bad image of Andromeda?
Very large one.
Yes.
All
Yep.
right. A very bad image of Orion,
Right.
the Pleiades.
But I bet when you took those, you were super excited.
I was. Oh man, I
I
thought
mean, we've all been there.
I thought this was the best in the world. Oh my God, I was so excited about this. But when you zoom in on some of this data, it's like, oh my gosh, it's not so great. I don't know. I did that. I think that's the Triangulum. That's the Veil Nebula. I've got that's the Bubble Nebula. Bubble Nebula again. Orion. I don't know. I was just goofing around with that. It looks like it's taken from the moon or something. I don't know. And I'm trying to get to, there it is. That's my very first California nebula. Looks pretty weak. It got a little bit better. I reprocessed it after I got some advice from some people like Adam Block. And then I just kept going and going and going, and things started to get a little bit better and started to get a little more confidence. So if you just keep it up and don't get too frustrated, I mean, things will eventually, improve and you'll feel a lot better about what you're doing. I just decided every day I was going to spend 15 minutes doing something to try to improve my processing skills. And over time, I think it worked. I think I did get better, somewhat in any event. And I'm trying to find a California nebula that I actually took, and I don't know where it is. Where are you, California nebula? Well, it's somewhere. I've got a version of the California nebula that actually there it is.
Yeah. Wow.
That version of the California nebula actually won NASA APOD, so I was particularly proud of that. So this can just demonstrate to you that if you just stay with it, maybe spend about 15 minutes every day trying to improve, you will definitely improve over time. Okay, that's my presentation for today. Questions?
Steven, I think that most of my questions are mainly about calibration frames. That was kind of pretty confusing and very new for me, like everything else. When you were doing the first example, you loaded some dark frames and then some flat frames, and you were going to run it. Is that correct? With only those two?
I thought I had the light frames in there.
And the light frame. Okay. Yeah, the light frames. But you were gonna run it with dark frames and flat frames. Is that correct?
Correct.
Okay. So you can run your pre-processing without bias frame or flat darks. Is
Right. And
okay.
and if you listen to there's a one of the YouTubers who I'm trying to persuade to come on to an AppSig meeting, Quiv, the lazy geek. I'm trying to persuade him to do a presentation for us.
It'd be fun.
He says that he's done extensive comparison and finds that bias frames and flat darks and darks are not needed if you have a camera like the ZWO or ZWO 2600 MC or the ZWO 2600 MM because there's very little amp glow. However, there are other cameras out there where there is amp glow, and then you have to have those dark frames to calibrate both the flat frames and the light frames because there's also amp glow in the flats, right? Because the same amp glow is always there. It's always present. And you have to calibrate that out using the corresponding dark frames. It's always there for that particular camera. But if you've got one of these ZWO cameras like the 2600 series or the 6200 series, I think maybe, is it the 533 as well? I think those are the three examples where the amp glow is so low that you don't need to have the dark frames to calibrate the light frames or the flat frames. Is that helpful?
Oh yeah. I got the 2600.
Okay.
I got already all the equipment, and that was the camera that I choose. I decided to go with the Air, the new one, because of
Okay.
the Bluetooth connectivity.
All right.
So that's the one I got, and I was reading a little bit about the glow and the graphic that explain a temperature versus glowing and all those things. So yeah, my impression was that they say that. I mean, my taking was that you can do dark frames as long as you're very good at it. If your dark frames are not really good, you can do more damage with this type of camera putting dark frames that not putting them. So
Actually,
you can,
that's a very good point, David. If your dark frames aren't truly dark, then when you subtract the light, the light minus the dark, and your dark frames are not correctly captured, yes, you're right. You're going to do more damage than you are good. This is true. I have made that error uh, where I don't know, I had some kind of light leak or something going on with my dark images, and I couldn't figure out why my images weren't very good. And so I started experimenting. So I just eliminated the dark images altogether, and suddenly I had a usable image. And I concluded that somehow the dark frame was not taken correctly. And I was calibrating it with an image with subframes that I shouldn't have been calibrating it with. So this is true. Absolutely correct.
okay. And when you don't include your darks, I remember right now I'm trying to look for, but I don't remember. I cannot find it. There is a function that you can put like the auto to replace the dark frames. Do you do that, or you just simply don't put them?
Uh, okay, so the only thing that I've seen that you can do is you can include a master bias and then and use that. That's the only other thing that I can think of. What was the procedure you
Okay, I think that I have it here. It say if you don't have a master dark, you can use cosmetic correction auto detect setting.
correct. If you don't, right. So there is and actually I use cosmetic correction anyway. Cosmetic correction does a number of different things that are good for your image, and it's automatically checked in the weighted batch pre-processing menu. So yes, you can cosmetically correct if you have no dark frames, and that will help improve the image.
Okay. So for me to start to make things kind of simple, I can just do my flats and I can do that outer, and that will be probably good enough to have a decent quality.
And in fact, some people would say that's the recommended procedure, David. Some people would say don't use darks at all. Quiv would be one of those individuals. He would say don't bother with the darks. Jim and I are also that same persuasion,
Right.
that it's a preferred
Right.
technique for that camera.
For that camera, right, right. Perfect. No, it has been, thank you so much, Steven. The first
Absolutely.
time I read that that calibration frame, I don't know if I was too tired or it was too new, but it was so confusing. But after going the third time and seeing a couple of videos and what you guys did today was amazing. I really appreciate that. It has been great. Please, thank you so
David,
much.
what's your camera?
The one I choose, I did the ASIR 2600 MC Air, the new one, they call the smart one. But I haven't used it.
Right.
I put all the equipment together last week, but I haven't used it yet.
Okay.
Well, good news, David, because assuming we go forward with the Messier Marathon, what we're trying to organize is a sort of an informal AppSig in-person meeting to help people set up their telescopes on the dark sky site, at the dark sky site, if they want to. And those of us who have been doing this for a number of years will, provide advice on setting up your rig, making sure that, answering any questions that you've got, helping you with any issues for polar alignment, balance, leveling, all of those things. So that's something that I'm working with Bob Circus to organize, so that if you can attend and you want to have some one-on-one advice on site, we're going to have a quasi informal AppSig meeting at the Messier Marathon to help people set up their rigs to collect data immediately before sunset, so that you can at least get things more or less set up. Then at sunset or at
Actually, it's going to be earlier than that, Stephen.
is it? Okay.
There's going to be several things, and I'm crafting the email now.
Oh, okay.
So Bill Hall is going to do a session about solar. How you do solar. He's going to demonstrate. He's going to have at least two scopes, and he's going to have a session about focused on solar. There's going to be Ben Hudgens, the great Ben Hudgens. If you want to learn how to star hop, he's our guy. He's going to be having a session about that. We'll have a session on Nina and setting up your equipment, and possibly a session on post-processing either later in the marathon or first thing in the morning. So that email is going to go out this evening. So
Okay. And I'll be around if anybody needs help doing things like polar alignments, even though the Messier Marathon will be ongoing. I'll be available to help people do things like, hey, I'm having a problem getting my polar alignment, or the ASI air isn't playing nice when it comes to doing the focusing, or whatever image or whatever problems people might have. I'm going to make myself available, assuming we have a good clear night. I'll make myself available to go from station to station to help people with that aspect. Only because I've done the Messier Marathon a couple of times now. So I'm going to spend my time trying to help people set up their rigs if it's needed. And then after I help everybody get set up, then I'll direct my attention over to enjoy the Messier Marathon objects. And I'm sure there'll be plenty of other people also available. Chris Ashford, if he's in town, I don't know if he'll be back from Colorado or not. Jim Potts, if he's available. David B is excellent. A lot of very knowledgeable people in the club. If they're there, I'm sure they'll be more than willing to help you and others out to get their rigs set up. So as you craft that email, Bob, put me down to saying I'll help people set up their rigs if they need it. If they want it during the Messier Marathon, and happy to help in that regard.
What date? What's the date? I wrote it down somewhere, but
I have 29.
Saturday the 29th.
Yeah.
March 29th?
Yes.
I have that 29, yeah.
So, and Brandon Hamill's going to be there that evening and leading some stuff too. So,
all right then. Any other questions?
You just missed a very windy day.
Yeah, it's a blustery day, and it's 9:07 on this blustery day, and I have an appellate brief that's due tomorrow. So I think I'm going to sign off for now and get back to work on my day job, and I'll stop the recording and say thank you all for joining us. We'll get this edited and uploaded to the AppSig YouTube channel, which, by the way, if you haven't done so, go to the AppSig YouTube channel and like and subscribe. And I will probably include, when we do this, when we upload this video, I will most likely have a link for you to download all of the files that I used today. So you can download those and sort of follow the same procedure that I used and practice with that data if you want to.
Stephen, did you see the text on the chat from Jim or Catherine?
Jim says, would it be interesting for the group to take a common set of OSC data and stack in the various softwares and compare the results? That might be a good idea. So
I'd be up for that.
What I'll do is, I've got my California Nebula data, although I've only got, I limited it to a few images. Do we want a lot of data for that, or do we just want
You'll need a lot of other data to make the drizzle work.
I was going to suggest, if you can see in the background, well, I'm just going to share my screen for a second here.
Your owl and surfboard, is that what it is?
Yeah, for those of you that don't know, I've had trouble. I'll just bring it up. With my 127, getting it to focus. And so I recently bought a Moonlight focuser. And my results, hopefully you can see my screen, are nothing short of extraordinary. And that's the owl and the surfboard, my first image that I've successfully gathered off my 127. And I thought maybe we could, as a group, collect some of this data and then work together and create a group image. We haven't done one for a while, and it kind of falls into line with what Jim is suggesting, because I'm sure some of you guys would collect RGB data with your color cameras. So
Okay. Well, this might be a good candidate for that. Any other suggested candidates? Chris, you recently did is it the Horsehead and the Flame Nebula?
Yeah. Not many people would have a computer that has the capability to process that, though.
Okay. That's because you use the 6200 camera, which is that right?
Yeah, all my images are full frame camera.
So that's going to be.
So if you do a 2x drizzle, that makes it a 244 megapixel image.
Well, I'll tell you what. I've got lots of California nebula data. I just didn't include it for our purposes today. So what I can probably do is create a link with a couple hours worth of California nebula data so that the drizzle makes sense, more than 15 frames. And then maybe I'll just send that out to everybody and ask that people have fun with it, try it in Pixinsight, APP, DSS, etc., to compare the results. How about that?
Sounds good.
That's good.
All right. Okay, everybody. Well, it's 9/11. I'm going to say goodnight and thank you all for participating. And I hope that we all have clear skies very soon.
Thank you, Stephen.
Thank you.
Thanks,
Good night,
Stephen.
everybody.
Thank
Bye-bye.
you. All right,
Good night,
bye.
everybody.
Bye.